Hello, astronomy class. I'm sorry I couldn't be there today. There's an emergency with my kids. I had to stay home with them. So I'm going to try to do your lesson on screencast. Bear with me. It's my first time using it. So what we're talking about today is telescopes. So first, I'm going to explain how two different types of telescopes work. I'm going to do that by using this virtual optics bench. And then as an assignment in your squad, I want you to try to recreate what I do in the virtual optics bench. You can see up here the web address for the virtual optics bench I use. What you'll do is when you recreate the telescopes that I created, you will take a screenshot and email it to me. Okay, so let's get started. First, we're going to talk about lenses because you need to know about lenses in order to understand how telescopes work. So we're going to use this to put in an ideal lens, and we will just drag it here. All right. The first thing you need to know about lens is a property called the focal length. The focal length is a point where all of the light through the lens gets focused to. If I put in a beam of light here, you will see that there is a point where all of that light gets focused. This would be the focal length. That is important because a refracting telescope uses two lenses. So we'll put in a second lens here, glass lens. Okay? But it's important what two lenses and how their focal lengths work. Now, for a telescope, the two lenses need to have overlapping focal lengths. There we go. All right, so they share a focal point. This focal length is shorter than this one, but their focal points are on top of each other. I can tell that because the light that goes through here comes out parallel again, just like this one went in. And that's what we want to see from a telescope. So this is how a telescope works. It takes light that's really spread out, and it focuses it, and it packs it back together tighter. This increases the resolution of an image. Things in space are very far away, and as the light from them travel out, the light gets more and more spread apart. And as that light gets spread apart, it's harder to see things about it. So what a telescope does is it gathers that light and packs it closer together again. So we can tweak how compact the light is by tweaking the focal length. Let's try that. And then just readjusting so that it's parallel again. Let's go crazy here, make it huge. See, that actually doesn't work well. We want it really small. We can try like that and move it really close. But anyways, you guys will have fun playing with that, trying to make the most compact telescope you can. There we go. That's a really good one. Look how compact that is. So this is your basic refracting telescope. Now, refracting telescopes have some downsides. When I get back, I'll show you some actual lenses so you can see how they work a little bit. But a couple issues are that in order to make a better telescope, you need to make bigger, thicker lenses to get better resolving power. And in order to do that, they get heavier and heavier, and they kind of sag, and they eventually start to like collapse, and you get distortion due to the change in shape. So refracting telescopes were the first telescopes, and they did a lot for us, but they're not the best telescopes. So we're going to clear out our optics bench here. All right, and now what we're going to talk about is a reflecting telescope. So I am going to put in a mirror, and it's going to be an arc. See, there we go. Look at that. Nice arc. Okay, so there's one mirror. Light comes in, because it's curved mirror, it focuses just like a lens, but instead of focusing through the lens, it focuses backwards from the mirror, because that's how mirrors work. Now, to build a reflecting telescope, much like a refracting telescope, you need two mirrors, one to focus the light and one to make it parallel again. So we're going to put a second circular arc mirror in here, and it's going to go before the focal point. And we're just going to adjust the curvature so that the light is mostly parallel. Oh, this one's a little bit harder. There we go. That's pretty good. It's a little hard to see because there's so many lines overlapping. Okay, let's get a better light source. That might help. We'll do a point source. That's not much better. One ray. There we go. I've got one ray now. And I kind of want it up here. There we go. Okay, that's pretty good. So ideally, there would be, for the telescope, there would actually be a hole here, which is where you would observe it. I'll put a second ray in so you can see how the light comes together. There we go. Sorry, my cell phone's going off.
It was me.
Alright, so see there, you can see how the two lights beams, which are incredibly far apart, end up much closer together after they go through the mirrors. So right about here is where you put your observation lens. Now, reflecting telescopes, you can see they don't require near the distance that refracting telescopes do. They also don't require nearly as large surfaces, nearly as thick as reflecting telescopes. But you can also tell that any ray that would collide with the smaller focusing mirror would get lost. So you do lose a portion of the picture, but in general, you get a much better resolution, more bang for your buck. So that is a reflecting telescope. So just to go over again, we've looked at refracting telescopes, two lenses where they share the same focal point, but not the same focal length. And refracting telescope, two curved mirrors, each curved in the same direction. Parallel light bounces off the first mirror, then off the second mirror going parallel again, but tighter packed. So that is a reflecting telescope. All right, so now take this information as well as this web address and try to make your own refracting and reflecting telescope. Feel free to work with your teammates. Remember, take a screenshot and email it to me. Thank you and good luck.